Hello everyone, my name is Mr. Elof Jansson, and today I'll be going over work on algebraic expressions. So at the end of this lesson, hopefully you'll be able to speak the algebraic language, and this involves recognizing and identifying conventions for writing algebraic expressions, identifying and classifying like and unlike terms in algebraic expressions, recognizing and identifying coefficients and exponents in algebraic expressions, and recognizing and differentiating between monomials, binomials, and trinomials. Alright, so let me start off by writing an algebraic expression. So, what I want you to do is to look at this algebraic expression and answer the following questions in your own head. So my first question is, what is the variable in this expression? Alright. Which number represents the constant? What is the coefficient of x? How many terms are in this algebraic expression? And lastly, is this a monomial, binomial, or polynomial? Alright, so let's go through everything from the start. So what is algebra? Algebraic expressions are different from normal arithmetic and multiplication. Normal expressions is when we do calculations with normal numbers. So, if I give you an example, let's say 3 plus 2 times 3 plus 4. What your first instinct should be over here is that we are going to be using BODMAS. So the order of operations. Firstly is brackets. So we're going to be looking for brackets here. Over here are brackets. So 3 plus 4 is equals to 7. In our next line, we are going to be writing everything over and only solving the bit with brackets. 3 plus 2 times, and what's in 3 plus 4 in this bracket? It's equals to 7. Alright, now we move over to operations, which are square roots, or any roots for that matter, and exponents. Are there any exponents or roots in this question? No, so we are done with operations and with our brackets. Next we have dividing. Are there any dividing operations here? No, so we are done with dividing. The D of BODMAS. Okay, next is multiplication. Is there a multiplication operation in this expression? Yes, there is. 2 times 7. So we solve that part of the equation. 2 times 7 is equals to 14. Alright, there are no more multiplication operations in this expression, so we're done. Now we move over to addition. Is there any addition in this expression? Yes, 3 plus 14 is equals to 17, and we get a singular answer at the end, so we are done with everything in BODMAS. So this was an example of a normal expression. Alright, so what's the difference between this and algebraic equations? Well, in algebraic equations we have something called a variable. So a variable is a letter which is inside of the normal expression. Okay, so it looks a bit different compared to a normal expression. Alright, so what are variables, and what are coefficients, and what are constants, what are terms? Let's get that out of the way. So to be able to do algebraic equations, or any algebra for that matter, it's important that you speak the language of algebra. So, these terms are important and are in the algebraic language. And these terms are important for you to understand in order for you to navigate the section of work. This is because we constantly be referring to these different terms to help explain how we are going to do different operations in algebra. So first off, what is a variable? A variable is a letter which represents an unknown quantity. So in our example, we said that 3x plus 2. In this expression, x would be the variable. So this can be any letter in the alphabet. Most commonly, it's x, y, or z. But it's not limited to these three letters. It can be A, B, C, F, G, any letter in the alphabet, from A to Z. And this letter, like we said here in the definition, represents an unknown quantity. We don't know what this variable is. We just know that there are 3 of them. Alright, but we'll get to that now. The 3 is a coefficient. So what are coefficients? Coefficients is a number in front of a variable. The coefficient is the number that is multiplied with the variable, indicating how many of that variable exists within the algebraic expression. So, hopefully you have gone to the shopping mall or to a supermarket with a parent or guardian or brother or sister, and you got a shopping list. So it might have looked something like this. So what if you've seen something like this on a shopping list, what does this mean? It means that you need to go to the shop and buy 2 loaves of bread and 2 bananas. This x, or this multiplication, means that we need to get 2 of each, 2 breads, 3 bananas. So in the same vein, this 3x means that 3 is being multiplied by x. There are 3 x's in this expression, and this is how it is written. So the 3 in front of the x is showing how many there are of this variable. Alright, and that is what we call a coefficient. Okay, so what is a constant? A constant is a number in an algebraic expression which is not related to the variable. This is usually a number which is a term on its own and which does not have a variable attached to it. As soon as there's a letter behind a constant, it becomes a coefficient. But since there's no letter attached to this number, we say that this number 2 is a constant. Alright, so why is this useful? Well, as previously stated, we said that x, the variable, can represent any number, and this changes the value of the expression. If x is equals to 1, we can take the expression 3x plus 2 and substitute a 1 into where the x is standing. So now if we know what the unknown variable x is, or what its value is, we can calculate the algebraic expression's value. So 3, substituting a 1 in where the x was standing, because we know that x is 1 now, we say that 3 times 1 is 3, plus 2 gives us 5. So when x is equals to 1, we know that the expression is equals to 5. Let's see what happens when x is equals to 2. So we write our expression over, and now we substitute 2 into where the x is standing. 3 times 2 this time is equals to 6, plus 2 is equals to 8. So now we know that if x is equals to 2, then our expression is equals to 8. Alright, and lastly, let's look at when x is equals to 3. 3x plus 2, substitute 3 into x. You get 3 times 3 is equals to 9, plus 2, and this gives us a value of 11. So hopefully you see the value in algebraic expressions. We don't know what this value of x is, but it is almost certainly any number. And when we find out what this value of the unknown variable is, we can substitute it into this expression and find the value of the expression. So algebra is just math that we are doing with an unknown variable. Alright, so how is this useful in a real world context? Well, let's say you and a few friends want to go eat at a restaurant, and you want to help, or you want to find out how much it might cost you to go eat at a restaurant. If you leave the waiter a 20 rand tip, and the hamburgers might differ in price from restaurant to restaurant. So if you want to write a formula for this application, we say that you are going to be eating 3 burgers. We are making the cost of a hamburger equals to x, and we plus 20 rand by this cost, and this is how we are going to find out what each of the restaurants will cost us. Since 3 times x means there are 3 x's, 3x plus 20 represents a formula of how we are going to find out what a restaurant might cost us. So now you find 2 restaurants. One is cheaper than the other. At restaurant A burger costs 30 rand each, and at restaurant B, burgers cost 40 rand each. I want you to calculate which restaurant you can afford to eat at if you have a budget of 130 rand. So let's do restaurant A together, and you can try restaurant B on your own. We know that the formula for the cost of you and your friends eating out is represented by 3x plus 20. At restaurant A, the cost of the hamburger, which is x, is equals to 30 rand. So 3 substitute in times 30 rand plus 20 means that 3 times 30 is equals to 90, plus the 20 rand tip gives us a total of 110 rand. Okay, so we know that at restaurant A, if you and your 2 friends get 3 burgers of 30 rand each, plus a 20 rand tip, it will cost you 110 rand. So now I want you to calculate what it would cost to eat at restaurant B. I'll give you 2 minutes to calculate this. Alright, so let's do it together. We use the same formula, 3x plus 20, to calculate the cost at restaurant B. 3 times x plus 20 rand, and x this time is 40. 3 times 40 is equals to 120 plus 20 will be a total of 140 rand. So at restaurant B it will cost you 140 rand to eat there. At which of these two restaurants can you afford to go eat with your friends? That's right, it's restaurant A. So that's an example of how we can use algebra in real life settings. Alright, so let's look at simplifying algebraic expressions. So before we go here, let's talk about terms. What are terms? In algebra, and in normal expressions for that matter, terms are different parts or components of an expression which are separated by pluses and minuses. Only these two. So let's say, for example, I write 3x plus 20. This is the first term in our expression, and this is the second term in our expression. So this is an example of an algebraic expression, but let's say in a normal expression, 4 minus 2 plus 3, how many terms are in this normal expression? Remember that pluses and minuses separate terms. So this is 1, this is 2, and this is 3. This is our first because it's separated by a minus, separating the 4 and the 2. This is our second term, in other words. And now there's another plus, or another thing that's separating our terms. It's the plus this time instead of the minus. And 2 and 3 are separated by this plus, so this is our third term. Alright. Okay, so sometimes an algebraic expression, just like a normal expression, is not in its simplest form, and you need to simplify it. So if we are going to simplify it, we can look at these two terms in the expression and use our knowledge of different types of variables to calculate it in its simplest form by adding like terms. So like terms are terms, remember, terms are which are separated by the plus or minus. So this is one term, this is our second term. Like terms are terms which have the same variable and can be added or subtracted since they share that same variable. Right, so over here the coefficient is 2 and the variable is x. Over here the coefficient is 3 and the variable is x also. Since the variable is the same here and here, we can add these two terms together. So if this is an x and that is an x, the variables are the same, so these two terms can be added together. What we do now is we add the coefficients together and as a plus sum. 2 of these x's plus 3 of these x's give us 5 x's. So if we can use the analogy of the shopping list again, if the shopping list looked like this and it said that we need 1 loaf of bread, and for some reason they wrote it as, secondly, we need 2 loaves of bread. How many loaves of bread in total do we need to buy from the shop? That's right, it's 3. 1 loaf of bread plus 2 more loaves of bread gives us 3 loaves of bread. So if we can say x is equals to loaves of bread, or use this analogy, we can say 2 breads plus 3 breads gives us a total of 5 breads. The only reason we can do this is because our variables are the same. But sometimes an algebraic expression can have more than one type of variable. Alright, so over here we have a 3x plus y plus 2. in this situation, the variables are not the same. There's an x here, there's a y here, and there's no variable here. So, can we add these three terms together? No, because they don't share this variable at the back. This one is 3x's, this is a y, and this is a 2. Again, we're going to use the shopping list analogy. If I say we need 3 breads and 2 cokes, which let's say are the y's, and breads are the x's, we can say we need 5 bread cokes. That is nonsensical. Nobody knows what a bread coke is because it doesn't exist. In the same breath, we can't say that 3x plus a y plus 2 gives us 6 xy's. So these are unlike terms and they cannot be added together. Alright. So beyond that, unlike terms are not always two different variables. They can have the same variable but have different exponents. So this is where it gets a little confusing, because you're going to say, so these two variables are the same. This is an x and this is another x. Why can't I add these two together? Because if you remember, this number at the top is an exponent. So if we write, for example, 2 to the power of 2, it means that 2 needs to be multiplied by itself twice. So 2 times 2 is equals to 4. If we say 2 to the power of 3, it means 2 needs to be multiplied by itself 3 times. 2 times 2 times 2 gives us a total of 8. So why is this important? Because this is one term, this is the second term. It's separated by a plus. But this one is x times x. X times x gives us x squared, where this is just a normal x. So these cannot be summed together. They are not alike. They are unlike terms. Alright, lastly we're going to talk about algebraic, different types of algebraic expressions. So firstly, we get something called a monomial. A monomial is an expression consisting of only one term. Remember, we said that terms are components of an expression, algebraic expression, which are separated by pluses and minuses. But if there's only one expression or only one term, so there's nothing separating this algebraic expression into two parts or two terms with a plus and a minus, we call this a monomial. Okay. So let's say there are two terms, 3x plus 2. In this expression, 3x is separated by 2 with this plus. There are two terms. In this situation, we call this a binomial. Sorry for that. Binomial. Alright, and polynomials are algebraic expressions consisting of 3 or more terms. So when you have something like this, there are 3 terms, 1, 2, and 3, separated by the pluses. We call this a trinomial. And anything more or equal to a trinomial is called a polynomial. So let's say 4x plus 3 plus z plus y. This is more than 3 terms. It's 4. We call this a polynomial. For that matter, if it's greater than 4 also, if we add another variable, a for example, and this turns into 5 terms, it stays a polynomial. Alright, so I want you to look at the following exercise. We're going to test our knowledge. Given the following expression, 5x plus y plus 3 plus 2x plus x squared. Here are 5 questions, and I want you guys to pause the video here and just try to do these 5 questions. Alright, so hopefully you could have done it. Let's start with number 1. How many terms are in the expression? So we said that terms are separated by plus and minuses. Here's a plus, so it's separating these into 2 terms, another plus, 3 terms, another plus, 4 terms, another plus, 5 terms. So there are 5 terms. How many variables are in the expression? Remember, variables are different letters that represent numbers that we don't know. So here we have an x, here we have a y. There's no variable here, so we skip it. Here's another x, but we already counted it, so it's still 2. And here's an x squared. But remember, x squared and x is not the same value, so this is a third variable. So in other words, there are 3 variables. Alright, so at number 3, I wanted you to identify the constant. Number 3 here has no variable at the end of it, so the constant in the expression is 3. Alright, for number 4, we needed to simplify the expression. 5x plus y plus 3 plus 2x plus x squared. Remember that when we want to simplify an equation, we want to take this complex equation and make it more simple. So we're going to look for variables which are the same and can be summed or minused to make it easier to read. So over here we have an x. Now we look for another x in the row. Over here is an x and here's an x squared. Remember that the x squared and the x are not the same, so this is the only one we can add to 5x. There's an invisible plus in front of this 5x because there's no negative, so it's always positive if there's not a negative in front of a 5. So 5x plus 2x gives us 7x plus y plus 3 plus x squared. Is there something else we can add together? No, so we stop there. This is the expression in its simplest form. Alright, for number 5, if x is equals to 3 and y is equals to 2, solve the expression. So you can either use this non-simplified expression, but to make it easier for yourself, you could have just used the simplified expression. 7x plus y plus 3 plus x squared. Now we substitute in our values. 7 times x, which is 3, plus y, which is equals to 2, plus 3, plus x squared, so it's 3 to the power of 2. So 7 times 3 is equals to 21, plus 2, plus 3, plus 9, and now we start by summing. From left to right, 21 plus 2 is equals to 23, plus 3 plus 9. From left to right, 23 plus 3 is equals to 26, plus 9, and 26 plus 9 is equals to 35. Alright, hopefully this was a good refresher course on our expressions. Just to go again over everything that we went through, we were able to recognize and identify conventions for writing algebraic expressions. We were able to identify and classify like and unlike terms in algebraic expressions, to recognize and identify coefficients and exponents in algebraic expressions, and recognize the difference between monomials, binomials, and trinomials, and also polynomials. I hope this helped you guys in any capacity. If you have any questions, feel free to ask your teacher, and And if you want help from me, I can always do my best to get back to you. Thanks so much for your time. Bye bye, guys.